Hello everyone, welcome back. In previous lecture, I have discussed about the chapter 1 that was about the principles of metal cutting and various metal cutting processes, okay, and various metal cutting operations as well. Now this is the chapter number 2 that is about the metal cutting lathe, okay. The earlier chapter was about the basic machine tools, chapter 1, and the metal cutting principles. Now, this chapter is basically describing about the lathe machine and the various operations performed on the lathe machine. Well, lathe machine tool is a father of all machines and it is mostly used for metal cutting operation. Wood cutting lathes are also available, wooden lathe cutting, but most of the application is in the metal cutting. Okay, now let us start with the introduction portion. First, here are the topics of the chapter. We will discuss the engine lathes, construction, all arrangement, principal units of engine lathe, type and size range of engine lathe, operations carried out in the engine lathe, turning and other operations. Okay, then attachment, extending, processing capacity of lathe engine. Okay, types of lathe machines, capstan and turret lathe in detail, then taper turning on lathe, how taper turning is done, then thread cutting on lathe using gear train and chasing dial, alignment test on lathes that we are going to discuss in the upcoming lectures. Now, let us see some introduction and working principle of lathe. Lathe is one of the most versatile and widely used machine tools all over the world, and it is commonly known as mother of all machine tool or father of all machine tools. The main function of lathe is to remove the metal from a job to give it required shape and size. So suppose we want to reduce a diameter, we want to cut a groove on it, okay. We want to put thread over it, okay. We want to make knurling operation. So various kinds of operations, shape and size reduction that can be done with the lathe machine. Okay. So the main function is to remove metal from the job. The job is securely and rigidly held in the chuck. Here there is headstock. Here headstock, it is fitted in the chuck, and here it is the tailstock which is used for the support purpose. And here it is the tool which is used for cutting the workpiece. Okay, between the centers on lathe machine and then turn it again a single point cutting tool which will remove the metal from the job in form of chips. Figure here shows the working principle of lathe. An engine lathe is most basic and simplest form of lathe. So here you can see this is the basic lathe machine. Okay, now it is having this chuck for holding the workpiece, while this tailstock is used for support purpose, and this is the carriage which is, or this is the tool post over which the tool is mounted, and the machining operation is done on this. This is the head box. Okay, so here there is the arrangement for pulley drive. Okay, so this is the drive mechanism, this is the lead screw. Later on we will discuss in detail about the various parts. Now here it derives its name from the early lathes which obtained their power from engines. The name of the lathe comes from the early because it's obtained power from the engines. Besides the simple turning operations as described above, the lathe can be used to carry out operations such as drilling, reaming, boring, taper turning, knurling, screw threading, cutting, grinding, and etc. Numerous operations can be performed. That's why it is called as mother of all machine tool or father of all machine tools. And the engine lathe name is obtained from the because it was used to obtain power from the engines. So all kinds of, apart from cutting or single point, using the single point cutting tool and removal of metal from the workpiece, various or numerous operations can be performed on the lathe machine. So the inventor of central lathe is known as Henry Maudsley. The was born as on an isolated farm near this place in the north side of the University College and educated over here in London. He was an outstanding, brilliant medical student, collecting 10 gold medals and graduated with MD degree in 1857. This is just for your information. Okay. Now there are various types of lathe machine. Okay. So there is speed lathe, center lathe or engine lathe. We have seen the engine lathe. Then there is bench lathe, tool room lathe, capstan and turret lathe, special purpose lathes, automatic lathes, and computer controlled lathes. We will see them one by one. Okay. So first let us start with the simple lathe, or this is the speed lathe. Speed lathe is the simplest of all types of lathes in construction and operation. The important parts of the speed lathe are the bed, this one, the portion over here over which this entire assembly, the headstock, carriage, and tool post are resting, is this portion is called as bed. It is basically made of cast iron, so that can absorb the all the load and the vibrations that are coming from this cutting operation. Okay, so this is the portion is the bed. This portion is called as headstock. This portion over here it is called as tailstock, and the tool post mounted on adjustable slide. This one is the this is the adjustable slide, and the tool post is mounted over here. This is the tool post, okay, and this is the adjustable slide. It has no feed box, lead screw, or conventional type of carriage. Okay, the speed lathe does not have any feed box, lead screw, or conventional type of carriage. In this, it is shown that there is one simple type of mechanism, that is the slider type. There is no lead screw arrangement. Okay, it can only slide over here. The tool is mounted on an adjustable slide. There is one adjustable slide, lock and nut type. Okay, with a work hand control, with moving this by rotating this handle, we can slide this complete post and move it to particular position. The speed lathe finds application where the cutting force is least, such as in woodworking, spinning, centering, polishing, winding and buffing. द मेजर एप्लीकेशन जो स्पीड लेथ है वो सबसे ज़्यादा कहाँ पे यूज़ होते हैं, जहाँ पे कटिंग फोर्स सबसे कम है, जैसे कि वुड वर्किंग में कटिंग फोर्स कम होगा। फिर जो भी स्पिनिंग ऑपरेशन है, ठीक है, सेंटरिंग ऑपरेशन, फिर पॉलिशिंग हो गया, वाइंडिंग, बफिंग, दिस टाइप ऑफ ऑपरेशन वेयर द कटिंग फोर्स इज लिस्ट, जब जहाँ पे कम से कम कटिंग फोर्स होगा वहाँ पे स्पीड लेथ यूज होगा। दिस लेथ हैज बीन सो नेम्ड बिकॉज ऑफ वेरी हाई स्पीड ऑफ headstock spindle. The name high speed lathe came because the headstock spindle is having very high speed. This RPM is very high. That's why it is called as speed lathe. Now, the another or second type of lathe is center lathe or engine lathe. The term engine is associated with this lathe due to the fact that in very early days of its development it was driven by steam engine. Okay, so earlier it was driven by steam engine, so that's why it is called as speed lathe, sorry, engine lathe or center lathe. This lathe is important member of lathe family and is the most widely used, similar to the speed lathe. The engine lathe has all the basic parts like bed, headstock, tailstock, but its headstock is much more robust in construction and contain additional mechanism for driving the lathe spindle at multiple speed. So here there is an arrangement for in the headstock or additional mechanism we can say, so that we can change the spindle speed. Okay, unlike the speed lathe, engine lathe can feed the cutting tool both in cross and longitudinal direction. Speed lathe, there were restriction in the cross slide, but here in this central or engine lathe, the cross or longitudinal directional movement is also possible with reference to the lathe axis with help of carriage, feed rate or and lead screw. The center lathes or engine lathes are classified according to method of transmission of power to the machine. Okay, and the power may be transmitted by means of belt, electric motor or through gears. Okay, so in this way the power can also be transmitted by means of belt, electric motor or through gears over here. Next type here is the bench lathe. This is the a small lathe usually mounted on a bench. Here it is one bench and over it is mounted. It has practically all the parts of engine lathe or speed lathe and it perform almost all operation, and this is used for small and precision work. The bench lathe is used only for small and precision work. Okay, it has all the parts. You can here see that there is tail stock, head stock. Okay, this belt and pulley drive is there for rotation of this chuck or the spindle we can say, and this is the carriage over which the tool post is mounted, and this is for the cross slide and longitudinal slide as well. Okay, and this is used for small and precision work. Next type of lathe is tool room lathe. Now this lathe has features similar to an engine lathe, but it is much more accurately built. It has a wide range of spindle speeds ranging from a very low to quite high speed up to 2500 rpm. This lathe is mainly used for precision work on tools, dies, gauges, and in machine work where accuracy needed. The places जहाँ पे सबसे ज़्यादा एक्यूरेसी चाहिए होगी डायमेंशन की, जैसे कि प्रिसीजन वर्क हो गया, जैसे कि टूल्स का मैन्युफैक्चरिंग हो गया, डाइस, गेजेस, मशीनिंग वर्क, तो वहाँ पे टूल रूम लेथ यूज होगा. ठीक है. नेक्स्ट टाइप ऑफ लेथ मशीन इज कैप्स्टन एंड टरेट लेथ. The here you can see the first figure is shown the capstan lathe, and the second one over here is the turret lathe. Okay, the development of these lathe results from the technological advancement of engine lathes now, and these are vastly used for mass production work. The capstan and turret lathe are mostly used for the mass production purpose. The distinguished features of this type of lathe is that the tailstock of engine lathe is replaced by a hexagonal turret. Here you can see this is the hexagonal turret over here. ठीक है, यहाँ पे आप देख सकते हो कि जहाँ पे मल्टीपल टूल्स हम यहाँ पे फिक्स कर सकते हैं with this hexagonal turret on a face of which multiple tools may be fitted and fed into the work in proper sequence, जहाँ पे नंबर ऑफ टूल्स हम यहाँ पे फिक्स कर सकते हैं और उनको फेड कर सकते हैं इन अ प्रॉपर सीक्वेंस. Due to this arrangement, several different types of operation can be done on a job without resetting of work or tools, and number of identical parts can be produced in a minimum time. सो यहाँ पे क्या पॉसिबल है कि जो भी सेवरल डिफरेंट टाइप्स ऑफ ऑपरेशंस है वो हम यहाँ पे परफॉर्म कर सकते हैं ऑन अ जॉब विदाउट रीसेटिंग ऑफ वर्क और टूल्स. जो टूल्स है उनको रीसेट किए बिना और वर्क को रीसेट किए बिना हम सेवरल ऑपरेशंस कर सकते हैं और नंबर ऑफ आइडेंटिकल पार्ट्स हम प्रोड्यूस कर सकते हैं इन अ मिनिमम टाइम. सो दिस आर दी कैप्स्टन एंड टरेट लेथ. Next type is the special purpose lathes. These lathes are constructed for special purpose and for jobs which cannot be accommodated or conveniently machined on standard lathe. Okay, so suppose we want to machine a large size of shaft. Okay, so for that we will require this type of special purpose lathe machine. The wheel lathe is made for finishing journals and turning the trade on railroad car and locomotive wheels. Okay, these are one example. जब जर्नल और बियरिंग्स जो है फिर रेड रोल्स कार है उनका टर्निंग करना है फिर या फिर लोकोमोटिव्स के व्हील्स हो गए सो उनके टर्निंग के लिए स्पेशल पर्पस लेथ मशीन्स चाहिए होगी. द गैप बिटवीन बेड लेथ in which a sector of bed adjustment to headstock is removable is used to swing extra large diameter piece, and the T slot is used for machining of rotors for jet engines. Okay, so here we can see here there is one removable part or this is a support assembly for supporting the large size of workpiece. The bed of this lathe has T shape. Here the bed is having the T shape. The duplicating lathe is one for duplicating the shape of flat or round template on the job. Okay. So these are the special purpose lathes. Another is automatic lathes. These lathes are so designed that the all the working and job handling movement of all the complete manufacturing for a job is done automatically. These are high speed, heavy duty, and mass production lathe with complete automatic control. They are having the complete automatic, just we have to fix the workpiece and after entering the code, okay, G code and M codes in the CNC machine, the complete operation takes in the automate form. So the another type is computer numerical control or computer control lathes. In the most advanced lathes, the movement and control of machine tool and its components are achieved by the computer numerical control or that is just called as CNC machine, and there is also the old one was called as NC machine, numerical control machine. And these lathes generally are equipped with one or more turrets, and each turret is equipped with varieties of tools and performs several operations on different surfaces of workpiece to take advantage of new cutting tool materials. Computer numerical control lathes are designed to operate faster and have higher power available compared with the other lathe machines. Now, these computer numerical control lathes are very highly used in the industry because they are having this quick changing facility due to the use of turret, as well as there is the new advanced cutting tools are used for the cutting purpose, and also the speed is very high, and they are also equipped with the automatic tool changers. There is a specific provision for changing the tool automatically. and their operations are reliably repetitive and maintain the desirable dimensional accuracy. In micro level dimension, the CNC machines are capable of achieving the accuracy in micron. Okay, and the surface finish is also achieved of high accuracy. The main thing required uh, is knowledge of the CNC programming and requires less skilled labor. Once machine is set, the initial level the skill is required is only in the programming part. Okay, the part of part programming, the G code and M codes are needed to be entered in here. So after entering, the tool follows the path as given in the instruction. If the program is wrong, the tool is having here the in machine, there is provision that if there is some wrong code, it will stop. Okay, so that will not damage the tool, but here the skill is required in the initial level or at the programming side, not on the working side. While on the conventional, the hand skills were very useful when it comes to the high finish and accuracy. So they are suitable for low to medium volume production. For low to medium volume production, computer controlled lathes are very much suitable. So these are the all the types of lathes. There we started with the this speed lathe, the various types: speed lathe, center lathe, or engine lathe. Then there is bench lathe, tool room lathe, capstan and turret lathe, special purpose lathe machine, automatic lathes, and computer controlled lathes. So these are the all types of lathe machines. So this is it for today's lecture. Thank you very much for listening me carefully. Have a nice day.